In 7.6, we're going to do a bunch of applications, and each application sort of has a nice systematic way that you can set it up that will help you solve it a little bit easier. So the first question that we're going to look at, I call distance, speed, time questions, because they involve distance, speed, and you guessed it, time. What we're going to do as a strategy is set up a chart with distance, speed, and time. You're going to enter the data that you know, and then based on what you've read in the question, you choose one variable to represent something that you don't know. So for example, in this question, we'll just scroll. Mario drove from Edmonton to Grand Prairie and back a distance of 300 kilometers each way. So we know, and I can put it in, my distance is 300 kilometers. Mario's average speed was 30 kilometers greater on his return trip than on his trip up. So this is something we don't know. We don't know the average speed. So we choose a variable. I'm going to choose S for average speed. And it was 30 kilometers greater on the return trip. So the return trip was more than, so this one is S, this one is S plus 30. And our goal in the chart is to complete our chart with only the one variable that we chose. So if we chose, the first thing they told us that we don't know was his average speed on the way there. On the way back, it was 30 kilometers per hour greater. Can I scroll down to here? Excuse me. So I'll let you finish writing those instructions out. And we saw this a little bit already in our last example from the last section. Trying to figure out my wording. Which one? The last part here?
Transfer equation.
Write an equation using. I can understand where that looks like. Using the chart. You guys are all so polite. Yeah, it's terrible. I'm sorry. So what we've done is we've entered the data that we know was only the 360. We chose a variable, which was S, which allowed us to do the S plus 30. And then to complete the chart, we have our formulas. Speed is distance over time, distance is speed times time, and time is distance over speed. And again, some people like this triangle method here. If I take out, I was going to take out a fancy pen, but apparently that's not going to happen very quickly. There we go. So, if you want to find distance, you put something over the distance, it's speed times time. If you want to find speed, well, now it's distance divided by time. If you want to find time, it's distance divided by speed. That's how that little triangle formula works for all of them. Me personally, I always start with one formula and then just use math to rearrange it. If you want to get the d by itself, can you see you can multiply both sides by t? That gives you a blue line. That that would give you the second formula. If I wanted to find time, right? If I had the second formula, I wanted to find time, I could divide everything by s, and that would get the t by itself, and that would give me this. So that's what we actually want to find here. I don't know the time. I don't know the time for each one. They didn't tell me. However, I can use my formula with the green box that time is distance over speed. This time will be 360 over s. And this time would be 360 over s plus 30. And maybe I put that s plus 30 in brackets because it's connected by the plus sign. So this is completing the chart with the formulas. And then very nice. Then we want to write an equation using the chart. So something in the question should allow us to write an equation. And that comes in the very end of the sentence. Or his total driving time was 10 hours. That means this time plus this time has to equal 10. And that creates, so this time plus this time. And I'm strategically leaving some space because I'm like, oh, equals 10. That's my equation. Now to solve that equation, oh, I almost strategically left space. I should put the plus. This is a rational equation. How do we solve our rational equation? The technique that we've used is to get the common denominator. So this one's missing the s plus 30 factor. This one's missing the s as a factor. And this one's missing an s and an s plus 30. And once those are the same, you can multiply both sides by that, which would simplify. And now we have an equation that no longer has fractions. If I multiply this out, the numbers are not necessarily nice to work with. 360s plus 360 times 30, it's a big number, 10,800 plus 360s equals, and if I multiply this out, I'm going to get 10s squared plus 300s. What kind of equation is this? It is a quadratic equation. So quadratic equations we solve by making one side equal to 0. I would make the 0 on the left because I like to have whatever my squared coefficient is, I like to keep it positive. So can you see that you would have 720s that you move to this side, minus 420s, and then subtract 10,800. For factoring, you have a common factor of 10. You could factor out that common factor of 10 or divide everything by 10. If you divide everything by 10, this will still be 0. You can do this because it's an equation. What you do to one side of an equation, you do to the other side of the equation. So if I divide everything by 10, I get the following equation. Yes? Why is it negative?
Yeah.
So these two here would make make 720s on this side, and I move it to this side by subtracting, and that's why it will be negative. Now, for most of you, I'd probably go, you probably don't know big times tables that are 1,080. So I might suggest going to your quadratic formula here. Just checking what is 60 times 18. Oh, it's 1,080. So it does, again, I would not expect you to be able to look at 1,080 and think, oh, I think it's 60 times 18. And then that works out with my 42. But quadratic formula is just something you could plug things in and solve, would be fairly straightforward. So now we get an average speed of 60 or an average speed of negative 18. The context of this question, negative 18 is a speed. How fast were you driving? I was going negative 18 kilometers per hour. You'd be like, okay. So the only possibility is S is equal to 60. Now, one of the things we can do, let's see, first of all, we'll reread the question. Determine Mario's average speed on each leg of his journey. So we now, I'm going to write in the answers here. We now know this is 60, which makes this 90. Let's check if this works. If he was going 60, you see that this would come out to 6 hours. And if I plug in 90 on the bottom here, 360 divided by 90 is 4 hours. Does the total add up to 10 hours? It does. Now, this question had some big numbers. You'll find that generally your distance, speed, time questions, like example 1, have smaller numbers which make things easier to work. So let's look at this on page 593. You might want to put the chart up at the top of the page, or maybe use that up already. We're going to make a chart with distance, speed, and time, and we have to read the question to find out what our situation is. A boat travels an average speed of 15 kilometers per hour in still water. The boat travels 12 kilometers downstream in the same time it takes to travel 8 kilometers upstream. So our two events here are downstream and upstream. Distance, speed, time. And we start filling in what we know. Do we know the distance that it travels downstream? Yes. That's 12. I can put a 12 in there, and the distance upstream is 8. What don't we know, and what we want to find, is the current. We know that you go 15 kilometers an hour when it's still. If you're going downstream, does the current make you go faster or slower? That sounds like a fire alarm. And the answer is going downstream, you would go faster. So if normally you go 15, does it make sense that this speed will be 15 plus whatever your current is? Which is, of course, what we don't know. And upstream then would be slower by whatever your current is. Now with our formulas, we know that time was distance over speed, so we can complete our chart with our formulas. Now we want to find that current, we have to create an equation. So there's going to be something in the word problem that's going to tell you how to create an equation. And in this one, there's the words that the time is the same. So that means this time here is equal to this time there, and we can create our equation. And once again, I'm going to strategically leave some space. These would get grouped together, because if I'm solving an equation, I like to get my denominators the same. I look at them, they currently are not the same. So this one's missing the 15 minus c, and this one's missing the 15 plus c. Now that I have my denominators the same, I can multiply both sides by that denominator, which in essence would get rid of my fractions. What am I left with? Still some bigger numbers. 12 times 15 is 180 minus 12c equals, and 8 times 15 is 120 plus 8c. But as far as solving, we don't have a quadratic formula, which is kind of nice. Just combine our like terms. I can put my numbers on this side, subtract 120, I'm going to add the 12c to that side. Divide both sides by 20, and my current, and it is a word problem, so you'll need units, maybe a sentence. The average speed of the current is 3 kilometers per hour. And the place where these questions get the meanest, as far as being mean, is sometimes they'll give you information in different units. And then you have to make sure all of your units are the same. Like if they told you the speed in meters per second, but the distance was in kilometers, then you'd have to change everything either to all be in kilometers or all be in meters. Just warning you, I think that sometimes comes up that our units go awry. So these are the distance, speed, time questions. The ones you can circle for this are 8, 11, 12, and 13. And creating the chart helps you organize your data all in terms of one variable, but you're going to have to specifically read the question to see what kind of equation. This first one, the time was the same. And the one that we did in the construct the understanding is total driving time was 10 hours. That told us that the one time plus the other time had to equal 10. So there's going to be something in the word problem that tells you how to set up an equation, but that equation could be different depending on what they say. I like these ones that do the same time. That's nice and easy. You just make one time equal to the other. Sometimes they tell you a total time, and you know you'd add them both up to equal something.